Last of chapter 5 is about mutual inductance. Okay, mutual inductance is defined as the ratio of induced EMF in a coil to the rate change of the current in another coil. So if you look at here, we have a picture here. We have two coaxial, means that they exist on the same axis. So kita ada coil yang pertama, here we have a solenoid here. Here then kita ada coil yang kedua. So there will be this N1 turns, this N2 turns. Okay, for the first part here, kita akan connect to the current. Okay, but there will be no current lah. So this one sebenarnya kita akan connect to resistor. Okay, so what going to happen is in primary coil. So kita kat panggil ni as a primary coil. Okay, atau primary solenoid ke, this secondary. Okay, so what going to happen is there will be changes in current in the primary coil. Whenever there is changes in the current, or means that changes in the magnetic field, changes in the flux in the primary coil, the changes going to affect or will be experienced by secondary coil. Means that if there is changes, there will be induced magnetic field produced in the secondary coil. Got that? Okay, katalah macam tu lah, faham tak? There will be changes, primary berubah, they will going to affect secondary coil and so on. So mutual inductance, the equation will be negative induced EMF in secondary coil over di1 over dt. Means that to calculate the induced EMF in the secondary, kita kena ambil kira the change in current in the primary coil. Okay, so in other words, we can calculate mutual inductance using N2 phi2 magnetic flux in secondary coil over I1, or M equal to N1 phi1 over I2, or else mutual inductance equal to mu naught N1 number of turns in primary coil, N2 number of turns in secondary coil, area which is cross sectional area because they're coaxial, area for both of them will be the same over the length. Okay, the length of the primary coil. The SI unit for mutual inductance will be Henry. Here's the example for the questions on mutual inductance. Find the coefficients of mutual inductance. We need to find the value of M. Okay, of the two coaxial solenoids of 5 cm radius and 30 cm long. So given that radius is 5 cm, L will be 30 cm if one solenoid and one has 10 turns, and 2 will be 1000 turns. Okay, so to calculate the mutual inductance, M equal to mu naught N1 N2A over L. So mu naught is 4 pi 10 negative 7, N1 it will be 10, N2 will be 1000. A, which is surface area lah, because it's solenoid look like this. So you pusing. So this will be the A. So therefore it's a pi R square over the length of the solenoid, which is 0.3. Remember, everything must be an SI unit. So you're going to get 3.29 10 negative 4 Henry.